Today's online class, we'll be working with importing soil lab data. We'll go through the process a couple different times. One time we'll go through and we'll import it, tie that data to the soil sample points from where those soil sample points were collected with a handheld. Then we'll also go back through the process and talk about how to link that soil lab data, join that up with one of the management zone maps that we created in the last class. And once we get that data brought in, we'll talk about how to set that data up in such a format that we can use it to do formula-based applications in the future. And then ultimately we'll talk a little bit about contouring that data and then creating a real basic application plan with that information. We won't get a lot into the formulas today. The formulas will cover that in an upcoming class, specifically just on the topic of working with formulas and how to create those in another class as we move forward here. So that's kind of where we're headed with the class today. The project that we're using is the same project we've been working with here in this series of classes. We've got our field 13 here as our primary field that we're going to be working with as far as that data is concerned and those kind of things. The first thing I always like to do whenever I'm starting to work with data coming in from a soils lab, I always like to look at one of those data files. So I've got the data files saved on my desktop here, and I've got a folder for class data, and I've got a folder here for my soil sample information. You'll see here I've got several different files here. I've got an SHP and an SHX and a DBF file. So I've got the ArcView shapefile for my management zones. I've also got my soil sampling points for field 13 as a shapefile. So again, I got the SHP, the SHX, and the DBF file there. And then I've got a CSV file that contains the data that's coming from the lab. It's very important when you ask for the data back from the lab that you request that you get each field as its own individual file. If they send you back one big file with everything in it, it's going to make your life a little tougher. So if at all possible, ask for them to send you back each field as its own file. If I double left click on this CSV file, it will open up in this case in Microsoft Excel, but it should open up in any database program that you have. And you'll see here's the actual data that's coming from the lab. A couple of the things that the program is going to ask about once we get into the process here is it's going to ask about the number of header rows and the number of title rows. So the number of header rows is how many rows of information there are at the top of the screen above your first sample ID, or your first point or your first area, the data for that. So you'll see in this case, row 2 here is our first sample ID, and everything above that in this case are the different titles for each of the different attributes that the lab has sent back to us. So in this specific situation, our header rows will be 1. We've got one row above the header row, and also the title row will also be row number 1. I'm going to modify this file just a little bit to give you an example of how some labs may send this back to you. Some labs may send you the data back and it may be in a format like this. You know, they may have your name, address, your city, your state, your phone, your email, a blank line there, and then it gets down to where your titles are actually at. So in this specific instance, we would have 7 header rows, and row 7 is also our title row. Another example is we may have a lab that sends it back in this type format. In this case, we would have 8 header rows, and the title row would be row 7. So we would have 8 header rows, and titles would be 7. And the last instance that you might get, again, dependent upon your lab and their format, you may get a sheet that comes back and it looks something like this, that there is no titles across the tops indicating what each one means. They may have a separate sheet that tells you what each row of information is containing, but in this specific type of instance, our header rows would be 0, title rows would be 0, because we don't have any header rows, we don't have any title rows. If we go back to our original format here, again, we're back to the 1 header row, and that first row, row number 1, is also our title row. So that's going to be important that we know the kind of the format that we've got that we're working with so that we can set the program up correctly to pull that data in. You'll see there's some information here that you may or may not need. There may be columns that are zeros, so you can kind of make notes of those things as well So as we're bringing that data in, that we can, maybe we want to ignore certain things, those kind of things. So, and we'll talk a little bit more about that when we start getting into the process. But that's kind of an example of what the data looks like and how we're going to need to know information about that actual CSV file or text file that we're getting from the lab before we bring it in. We'll go ahead and close back here to the main part of the program. To start the process of bringing the data in, we're going to go to the Read Job Data, or we can go to the File menu and choose Read Job Data. Either one of those is absolutely fine. The type of data we're going to bring in is actually under the generic, and we're going to choose the CSV, soil sample CSV or TXT file format. The program will remember the last place that you've read that type of data from. So you'll see here it's already went to my desktop, the class data, and that soil sample folder. You'll see here if I expand this column out, you'll see there's our Chaffer 13 soil test results. So I can go ahead and highlight that. At the bottom of the screen, since we're working with soil sample data, none of the things down here really apply. So we don't need to worry about changing any of the changes there. We can go ahead and click OK. This is going to bring up our generic import screen. The generic import screen up here in the top left-hand corner. It's going to ask whether the data that we're bringing in contains the coordinates or values, or do we want to join that with an existing shapefile, which is what we're going to want to do in this instance. If your lab has done all of the sampling and everything for you, and they've given you a CSV file that has a column for latitude and longitude, you could choose that top option, but there's very few. I don't think there's any labs out there that are doing that any longer. If they're collecting the data, they will more than likely send it back to you as a shapefile, which we could import just as a generic background image for that field. So in this instance, we are going to be joining it with the shapefile from where we've went out with maybe our FarmWorks mobile, and we've logged those data points. I'm going to go ahead and use my Browse button here. Again, it's went to that class data soil sample folder. It's remembered that. You see here we've got two separate files. It's only showing us two files, even though when we looked at the folder, there were a lot of different files there. It's only showing us the SHP file for each one of those ArcView shape files. The program will automatically bring those other associated files in automatically. So this time we'll go ahead and choose our soil sample points shapefile, and we'll click Open. On the top right here is where I talked earlier about the header rows and the title rows. Again, it's going to default to 1 and 1. If your format is different from that, you would need to change that and update it to the correct information. The delimiter, since it is a CSV file that we're actually working with, that by definition is a comma delimited file. If your lab gives you the data in a text file format, you would need to know what separates the data items on your text file, whether that be a comma, a semicolon, a space, or a tab, maybe even a colon. Those would be some other options that you might have to choose. We'll talk about the template here a little bit later, and the save template. We'll come back and address those after a bit. The coordinate system here on the left-hand side should automatically default to whatever your shapefile is. So should pick that information up and set that automatically for you. In this case, ours is just standard latitude, longitude, WGS 1984 format. On our layer file join here on the right-hand side, basically it's going to want to know what information from our shapefile, so from our log data points, what is the attribute that is going to match up with our sample ID coming from the lab. In this case, sample ID is the only attribute we've got on the shapefile. And our text file, you'll see again, here's all of our different headers. And we just need to select our sample ID option from it. It may be called sample ID, it may be called soil sample number, may be called sample number, it may be sample, could be any different type of terminology. But what we need to know is basically when we look at our map, when we look at whatever the first point number is, we need to know what number we need to match that with on the database so it knows what data to import to that data point. Typically it's going to be sample ID or sample number. Down below here in this little spreadsheet area are all of the different attributes the program found on that CSV file. And this is what it's going to pull in, the information it's going to pull in and attach to each and every data point. So if there's things that you don't necessarily need to have specifically on every point, we can go ahead and remove the check marks from those. So I'm going to go ahead and remove the option from grower and number. When we bring this job in, it's automatically going to be associated to a specific field. So we don't need to worry about the grower or client or the farm level. We can go ahead and uncheck those. We'll associate that a little bit later. The rest of the items as we move across here, sample ID, we just need to leave it set as a number type attribute. The rest of the items, we are going to want to choose the specific attribute type from the drop-down list. So for our CEC, for example, we're just going to scroll down our list and find our cation exchange capacity. Our organic matter, we'll scroll down and find organic matter in the list. We've got pH, which actually in our FarmWorks program is listed as soil pH. We move across to some of the others here. We've got a BPH, which is our buffer pH. We've got our P1 test, which is our phosphorus level. And we've got a CA there for our calcium. You'll notice that as I'm selecting these items, the program is automatically filling in the unit of measure. The units of measure are the standard units of measure for each of these different nutrients. If your lab is providing you the data in a different format, which we'll get to here in a little bit, we're going to want to not change this unit. It does allow you to change it, but I would definitely recommend that you not do that. I would recommend that you would set up a new attribute here at the very top so that we can set it up so that it defaults to the correct unit of measure. If we change it from this drop-down list, the program will take the data and try to calculate that change. So it's going to automatically still bring it in as parts per million, but if we tell it that this pounds per acre coming from the lab, the program is going to try to calculate or back calculate that pounds per acre back to parts per million, which is definitely not what we want it to do. Again, we'll cover that a little bit more here in a little bit. So I just wanted to point that out, that the program does automatically fill in the default standard unit of measure for the different attributes there. So we'll get our K here, we'll get our potassium. We get to the ones with the percentage signs on them here. Those are our base saturation values, and we've got those in our list as well. Is actually not one that we need, so let's go ahead and we'll uncheck that hydrogen. We'll uncheck the field number. Again, we're going to associate the entire job with that field. And this last column is actually one is a potash recommendation. So we don't want to, if we choose potash from our drop-down list, you'll see that it's going to default to parts per million. And that's definitely not what we want it to do. We don't want it to convert that to a parts per million. We want to keep that as a pounds per acre. So what we're going to do in that instance, we're going to come to the top and choose the Add Edit. And I'm going to add a new attribute called potash rec. I'm going to leave it as type. The number of decimals is the decimals is how many places after the 0 that we want to carry that number out. We'll just say it's 0 there. We'll just leave it as whole numbers. I'm going to choose simple units. And now from this list, I'm going to choose pounds per acre. And click OK twice. And now we've got that new attribute that we've set up called potash rec, and it's set up as pounds per acre. Once we get all of the information across the bottom set up, now is when we're going to use this Save Template button. What this template button will allow us to do is to save that format that we've got on this entire screen, and then we can use that and not have to go through and select all of those items every time. Typically, the data you're getting back from the lab is always going to be in the same format, so you're not going to need to change that from file to file as you're importing it. We're going to allow you to set up the set up a template for that. So maybe this data is actually coming from Waters Lab. So I want to actually save the template as the name of the lab that the data is coming from. And you'll see that that's filled in there at the top. Any other additional fields when we come in, once we've selected our join data file here, then all we need to do is select our template. The program will then automatically fill in everything else for us. We won't have to go back through and manually do that. Once we click OK, it does bring up the farming box. The only thing that you have to change in this farming box is it's very important that you get it associated with the correct field. So if you click on the gray button there next to field and come into our Chaffer Farms Open Doug's Farm there and choose field 13. So now we've got our field 13 chosen there. If you would like to associate this with a specific crop enterprise, you can. If you leave it blank, the program will set up an unidentified, unknown crop and then put that file underneath it. So depending upon how you want that to fall, you've got a little bit of flexibility there. As far as the date, some folks will go back and change that to the date that the samples were pulled. Others will just leave it default to the date that they're bringing that data in. So again, completely and totally up to you on what you do there as far as that. The rest of the information, again, if you want to fill it in, you can, but definitely not required. So now if I click OK, now underneath this unassigned crop, you'll see there's our soil test results. If I go ahead and double click on that, now on our map, you'll see that we've got all of our different attributes. If we select any of the other attributes, the program will update the legend and change the colors on the map so that they more match and update to what those values mean. That's the process of bringing the data in. From there, typically you're going to want to contour that data, get that data to fill that field out a little bit more. So zoom out just a little bit so you can see the entire field boundary. Now to create a contoured map, we'll start there. So we'll go underneath our soil pH based data here, and I want to choose the Add Views button. I'll choose the contour option. I'm going to back our cell size down to 50 feet. And this time, since our data points are far apart, we are going to need to use the inverse distance option. When it comes to the search radius, I know this field's set up on a 2.5 acre grid, so I know that 850 foot search radius is going to work well for me. If you're not sure and you want to get a kind of a good place to start, if you use your measure tool, which is the little ruler here, and you measure diagonally between two data points, and I always like to go maybe just a little bit further than the distance of those data points diagonally, that'll give us a good place to start as far as coming up with that search radius. What the program does is it uses that search radius and neighbors so that as it's moving from data point to data point, it knows how to ramp up or ramp down those values to smooth that data out and make a more estimated map as far as what's happening in the different parts of the field. The fill blanks is going to make sure we fill all the way to the edge of our field. And the smoothing, since we are working with a contour map, the smoothing is going to allow the program to smooth out those lines. The higher you have that percentage, the more smooth and free-flowing those lines will be. The lower you have that percentage, the more jagged those lines between your different rates will be. So in this case, again, we're working with our pH, and once I hit OK, see the program's going to create a contoured map of the entire field filled in based off of those pH values that the program was able to import. Another example or another option for you, we'll talk a little bit about the contour view. The contour view is only going to be usable if you're going to use this to make prescription maps. Will only allow you to create simple application maps. It will not allow you to apply a formula to this contoured view. A simple application rate means basically you're going to take and you're going to punch in the different values. If you're going to want to use any type of formula to have the program help you calculate those rates, then instead of doing a contoured view, we would need to, when we do our create new view, we're going to create a gridded view. I'm not going to change any of the other settings here, and once I hit OK, we can kind of look at the differences between those maps. So this time we've created that gridded view. See, the lines between are much more blocky, and I can select individual different areas, and I can get values for, in this case, the pH, or if I've selected an area on our map, and we go to our information tab, on a gridded view, the program has broken that map down into those 50-foot squares, and we have a value for every one of our attributes that was sampled coming from the lab. So we've got everything from pH to buffer pH to CEC. All of those things have a value in a gridded view. If we look at a contoured view, if I switch back over to the contoured view, select an area on the map, and now we go to our information tab, you'll notice that the only attribute that has a value is whichever attribute we had selected when we created that contour view. Well, this is the reason we're not going to be able to use it for a formula, because the only number that we have available to use is just that soil pH number. If I open up the other attributes here, you see under soil pH we've got both the contour and gridded view. If I open up the others, you'll notice all I have is just the grid view. So again, we can still change the map to look at those different grid views to see the values there. There's our potash recommendation map that we had. So there again, it's filling in values. The legend itself on this one is actually, there's other values in between. We may need to edit that legend. So let's go in here and choose equal ranges, or let's go statistical and apply. Oops. Let's go 200, low value 100, value every 50. So now we've got our application rates there broken out a little bit better, so you can see the actual applied rates for that potassium recommendation. But if we look at any of the others, we've actually got a map there that we can work with. So there's the difference between our gridded and our contoured views when we're working with the lab data. Now the next thing I want to do is I'm actually going to go back and I'm going to go through the process again, and this time we're going to link that with our management zone map that we created. So if you remember our management zone map from the other day, we're actually going to link that data to that management zone map. The first thing that we have to do is we have to export this management zone map out of the program. We need to have it as an ArcView shapefile, and then we'll just browse and select our output file. See, I've already got that done, so it's already listed there for us. So once that's done, we've got that map sent out of our program, because the only way we can tie the lab data with it is we have to bring the map and the lab data in at the same time, as again through our read job data process. So again, I'm going to go ahead and choose my Chaffer 13 soil results there, and we'll click OK. I'm going to choose to join the data file with an existing shapefile. Choose my management zone map this time. Our template will still be there. You notice everything down below there already filled in for us. The only thing that we need to change here is the sample ID is named a little bit differently on this shapefile. So it's going to be sample underscore ID. Still going to match up with our sample ID number. As we move on across the bottom here, you'll see all of our attributes we had set up before, but then there'll also be the attributes that are coming in with the shapefile listed there. And the only one of those I'm going to actually keep is the MUSYM, which is our soil type abbreviation. So I've got those all selected now. I can go ahead and click OK. Again, we need to make sure we associate it with the correct field. So we'll come in and choose field 13. And I'm going to come up here to the job name. I'm going to rename this and add the word zones at the end of it so I can differentiate between the two. Call it soil test result zones as my job name, so that when I look at my tree view here on the left-hand side, you can see there's our soil test results zones. I can differentiate that from my one where I imported with the points. So now if I go ahead and double left-click and display that soil test result zones, again, we've got all of our different attributes. We can switch between the colors. The one thing that you'll notice here with this coming in and tying that to an area layer, there is no way to contour or anything like that. The data is already filled in, so if we select any of these zones, go to our information tab, we've got a value for every one of our attributes for that zone. So there's no way to create a contoured view because the map's already completely and totally filled in. So that's going to be one thing that you don't have to do when you're tying it to a management zone type map as you're bringing that data in. Like I said, by setting up that template, it makes that process pretty quick and simple, but it does allow you to go ahead and get that data brought in. Let's go down here to our pH map, our soil pH map, and we'll talk a little bit about how to create a simple application map for this one. I'm going to go ahead and take my soil pH value. I'm going to right-click on it, and today we're only going to do the simple application, so I'm going to choose that Create Simple Application. You'll see that the farming box has actually used all of the items that we had in that practice spray job the other day. I'm going to go ahead and cancel out of it. So you'll see here's our working group. That's what it's tried to use in that job. Well, that's not the supplies we want to use for this job. So we're going to hit our double up arrow to remove those supplies. I'm going to come back in underneath my fertilizer, and I need to add another new supply here. Let's add lime in here as a supply. Set up underneath fertilizer and lime. We're going to buy it by the ton. We'll say our cost is $40 a ton, and our distributed unit is $40 as tons as well. And we'll go ahead and click OK. So now we'll add that lime to our working group. Now if we choose our right-click on our base data here and choose Create Simple Application, you'll see that it's brought up our job name. It's filled in the name of the field with the word application after it, picking that up from our job type. When I'm creating prescription maps, I always like to go in and add the supply name at the end of that as well. I'm just going to, again, help keep things straight as you're looking through all the different jobs, as you're moving forward, especially if you get into the point where you're doing a lot of variable rate prescription map writing for each of the individual fields, whether that be a lime map and a planting map and a starter fertilizer map and a 28 or whatever it might be. Might be an herbicide variable rate plan, whatever the case might be. You see the field names filled in for field 13 there. We do want to assign this to a crop enterprise this time, so I'm going to go ahead and choose my 2015 corn. I'm going to go ahead and leave the dates there where they're at. That's fine. You'll see the program's already marked as a variable rate application. And once we click OK, now the program's brought up our VRA summary screen. Basically, this is where we're going to put in our different application rates. The rates that are there are just the pH values that transferred over. So we're going to say maybe in the area where pH was 6, I want to apply, I'll go ahead and apply a ton of lime there. We're at 5.95. We'll go ahead and do a ton of lime for that area as well. The light blue area, we're at 5.75. Maybe that area we'll go ahead and bump up to a ton and a half. Now we're at 5, and maybe we want to go to 2.25 tons in that area. We do the same thing in the blue area there. The red area where the pH is 5, let's bump that up to 3 tons. And maybe 3.25 tons in the purple area. So now we've updated our actual application rates. Down here at the bottom, you'll see the program's going to fill in our average application rate, which our average is going to be 1.79. Our total amount of product needed is at 118.25 tons, and giving us our area. And based off of the cost that we set up, that $40 per ton, it's giving us a cost value there. Another option that we've got with the variable rate writing here is we can go in and do an adjust here. So if we go into this adjust, we can adjust our total quantity, we can adjust our total dollars, whatever we would like to make an adjustment, and the program then will back figure our rates then to get us down as close as it possibly can to that total quantity or that total cost. So maybe this year, instead of applying 118 tons, we're saying, well, maybe we can't quite get all of that this year. Maybe we want to apply just 60 tons of that this year. So we go ahead and hit OK. You notice the program will then prorate each of the areas, back them down as far as the application rates to get us fairly close to our 60 tons that we're wanting to go ahead and apply to the field. So that's another way to use the program. So if you wanted to do this over a 2-year application to get the pH back up where you needed it to be, that's one way you could come in and do that. You could do the 60 tons and then create another duplicate job, do the 58 tons to get you that 118 that you really needed to put on that field. Once we choose Save and Close, now if we look at our Jobs tab, you'll see there's our application job with lime. It's check marked, letting us know that that map's still being displayed on our Map tab. You'll notice that the clipboard here does not have a checkbox on it. That means it's a planned job. So it's something that we're planning on doing in the future. With it being a planned job, we can do a right-click on it, choose Work Order and Console. Once we've done that, you'll notice again, it's earmarked it with the little data card there, letting us know that it's ready to be written out. And then we just need to go through the right job data. We're going to send that out to an FMX. We can choose our Trimble and FMX, browse to our drive location, and then once we hit OK, it'll finish through that process of writing that data out. If we were going to send it out to the FarmWorks mobile program, we could do a right-click, work order, and mobile. If we had connected farm, when we go to this work order, below mobile here would be all the different devices that are connected through Connected Farm Office Sync. So you could send prescription map and job directly to that monitor in the field through the wireless connection there with that Connected Farm option, Connected Farm Office Sync option.